Welcome to my presentation. In this presentation, let us look at an example related to solving quadratic equations by factoring. Let us say we have an example of this type. Example, a to the power of 4, a to the power of 4, let me write this a little bit more clear. This is, we want to solve this problem, a to the power of 4 minus 3a to the power of 3 minus a to the power of 2 plus 3a is equal to 0. Okay, so we want to, in this particular problem, we want to solve this polynomial equation which has 4 factors, isn't it? A to the power of 4. Therefore, we will have 4 answers to this particular example problem. So the way to do it is as follows. Step number 1. Step number 1. In here, we're going to look at all of the equation on the left hand side and then say, is there anything common? What we see here is a is common. So if we were to pull out a as common, so we will be left with a to the power of 3 inside the brackets minus 3a to the power of 2 inside the brackets minus a plus 3 is equal to 0. And if we were to look some more, we can write this as between a cubed and 3a squared. We can write this, we can pull out a squared as common, and when we pull out a squared from a cubed, a is left. When we pull out a squared from 3a squared, 3 is left. And then again, between negative a and positive 3, negative 1 is common. If we pull out negative 1, we can write in this set of parentheses as a minus 3, and we close brackets, and that is equal to 0. Therefore, we can come back here, and if we call this as step 2, we are factoring by grouping now. And if we were to come back here and then do some more, by looking at these terms, a squared times a minus 3 and then negative 1 times a minus 3, a minus 3 is common. So if I were to write that as step number 3, now we are beginning to factor it. A minus 3 is common, and what is left in here is a squared minus 1. I'm going to write that in the second set of parentheses like that, and that is equal to 0. And we pretty much factored all the terms. So we can write this as a times a minus 3, a squared minus 1 is equal to 0. Okay, now we are looking at a squared minus 1. We can factor that some more, and I'm going to write that on the side here. A squared minus 1, I can write this as a squared minus 1 squared. 1 squared is still 1, but a squared minus 1 squared is in the form of x squared minus y squared form, isn't it? X squared minus y squared, we can write that as x plus y times x minus y, though that is the expansion of the difference of two squares. So therefore, for a squared minus 1 squared, I can write that as a plus 1 times a minus 1. And therefore, I'm going to come back in here and then write this as a times a minus 3. And then instead of a squared minus 1 squared, I can write that as a plus 1 times a minus 1. A plus 1 times a minus 1, and this whole thing is equal to 0. And now, as you can see, in here either a equals to 0 or a minus 3 equals to 0 or a plus 1 equals to 0 or a minus 1 equals to 0. We are using the 0 factor property, and therefore we can write this as either a equals to 0. Let me write it this way. I'm going to write that as step number 4. Step 4. in here either a equals to 0 or a minus 3 is equal to 0. From here we can find the value of a as equal to positive 3, isn't it? Because if we were to add positive 3 to both sides of the equation, positive 3 and negative 3 cancels out on the left hand side of the equation, therefore we are left with a equals to 3. The third part is a plus 1 equals to 0. In here, where if we were to subtract 1 on both sides of the equation, the positive 1 and negative 1 cancels out on the left hand side, therefore we are left with a equals to negative 1. And the last one, a minus 1 equals to 0. In here, when we add 1 to both sides of the equation, the positive 1 and negative 1 cancels out, leaving us with a equals to 1. Therefore, the three answers, therefore the three solutions we have, the four solutions we have are a equals to 0, a equals to 3, a equals to negative 1, and a equals to positive 1. These are all the solutions which satisfy this polynomial, and it has four factors. Whenever we have a polynomial and then the highest power kind of indicates to us that is we will have that many number of solutions for that particular problem. Okay. In my next presentation, we shall look at some more examples related to solving polynomial equations using this procedure.